So let's talk about another measure of acid-base strength, which is percent ionization. So here we have, I've done the icebox already, and we have a 0.1 molar solution of HF, and we found that the equilibrium concentrations of 0.1 molar HF, we have 0.0927 molar HF and this much of both F- and H3O+. In order to calculate percent ionization, we must take the conjugate F- over the total, okay? So in other words, our total concentration is 0.1 molar, or 0.00763 molar plus 0.0927 molar. We put the conjugate base concentration, the conjugate concentration, over the total concentration, multiply it times 100, and that gives us our percent ionization. And percent ionization is basically what percent of the total has dissociated or reacted in order to form a conjugate. Okay, so now that we have that information, let's do one ourselves. What is the percent ionization of a 0.1 molar fluoride solution at equilibrium? And we talked earlier about what fluoride's pKb is, so hopefully you can either that or you can look it up in the book, but give this one a go. Our answer is A, 0.00126%. How will we find that? Well, if we calculate equilibrium concentrations of 0.1 molar F-, okay, we get these equilibrium concentrations based on its pKb, okay, and then we take the percent ionization is the conjugate, which is our HF, over the total. In this case, the total has not been effectively changed because X is so small that we still basically have 0.1 molar fluoride, okay? We make very little of the conjugate, and therefore our percent ionization, or our percent of reaction, is very low because the reactants are really favored in this equilibrium. Hopefully that made some sense.